I'm Rush Holt. I'm the CEO of the American Association for the Advancement of Science and executive publisher of Science Magazine and our other publications, and a longtime participant in the Golden Goose Awards, long before I came to AAAS. It is the brainchild of my good friend Jim Cooper, who is right here. Representative Cooper from Tennessee had a real brainstorm. Just, it's as good as the brainstorm that some of these scientists have had. A very clever idea for helping us tell stories about the value of research, how it works, why political meddling in the process is not a good idea, why the scientist curiosity passed through the scientific review process is a whole lot better than a hunch from a bureaucrat or a, let's say, member of Congress. And a number of organizations are really proud to be working on Jim Cooper's idea. AAAS was one of the founding organizations of the Golden Goose Award, which highlights the serendipity that goes into so much research and discovery. And sometimes even the oddest sounding ideas turn out to be incredibly valuable. Valuable to our culture, valuable to our economy, valuable to our health and our welfare. And other founding organizations, most of whom are represented here, deserve thanks. 9 founding organizations, 8 besides the AAAS, the Association of American Universities, the Association of Public and Land-Grant Universities, the Breakthrough Institute, the Progressive Policy Institute, the Richard Lounsbury Foundation, the Science Coalition, the Task Force on American Innovation, and United for Medical Research. All of these organizations support this to tell the story, or the many stories, or at least a few of the many stories of research. This research helps us build healthier, safer products, revolutionize control systems for everything from digital cameras to entire subway systems, to shining spotlights on the way that we humans affect the world around us. This kind of research can help us save species from extinction, for which there are good scientific reasons. And this year's awardees are wonderful examples of how science works. And that's what it's all about, telling stories behind scientific breakthroughs, so that, well, most of us think in terms of stories, don't we? So that every American, from policymakers here to your constituents, everyone around the country can see what it means to think like a scientist, to follow your curiosity, to delight in discovery when the scientific process runs its course and your idea bears fruit. So over the past year, story after story have been submitted to us. And this year's Golden Goose awardees are really great examples of how staying curious, engaging your critical thinking skills, challenging your biases, not letting other people's biases divert you, can lead to incredible discoveries that indeed can change the world. So I'm so excited to be here to celebrate these stories. I hope they inspire you. I hope through our video streaming here, through the stories that we tell, through the word that you will spread, it will inspire other researchers and young researchers yet to come. I can't tell you, well, how excited I am about it, but I can tell you how effective this can be. My 16 years in Congress have taught me, or they did teach me back then, how important stories are, how important it is to defend the research process. It doesn't just happen. And so I thank Jim Cooper for giving us this terrific format for telling the story, to defend the idea of research and to defend researchers against small-minded ridicule. So we're proud to be leading this effort today, AAAS and the other organizations, and we want to make this something that goes long into the future. Well, now I'd like to introduce our MC for the evening, Mr. Frank Sesno. You know him as a journalist, as an author, as a professor, and he is our Master of Ceremonies this evening, Frank Sesno. Thanks.
Well, thank you, Rush, and good evening, everybody. Okay. Who's not been to a Golden Goose before? First-timers. All right. How many scientists in the room? How many science funders in the room? Okay, we know where the heroes are. You're all over the place. I am so thrilled to be back. This is the fourth time I've had the privilege to emcee this ceremony, and especially this year, to hang out with people who discover and actually do something here in Washington has a special resonance, and who contribute to the greater good. Rush, you talked about story, and I just need to say off the top, this is music to my ear. As you know, I'm the director of the School of Media and Public Affairs over at the George Washington University. I started a project several years ago called Planet Forward. It's all about story and storytelling around sustainability and science. We have students from all over the country who we challenge to tell a story about moving the planet forward and about the discovery and the invention and the research and the innovation that can do it. And what they have discovered in doing that is that there's power there. People remember story, right, Congressman? They remember story, and that's what they relate to. So you will hear a lot of that this evening. The Golden Goose Award celebrates silly-sounding science sometimes, but that has returned always serious benefits to society. So tonight, we're going to honor 3 teams of federally funded researchers whose work may have seemed or sounded silly at the time, maybe odd, maybe a little obscure. Sometimes it was the subject of criticism, maybe even a joke or two, but it led to significant benefits for society because that's what discovery does. Nominations for the Golden Goose Award can come from anyone. So if you have a story to tell or a scientist to support, please share it at goldengooseaward.org. You don't need to do that right now, but soon at goldengooseaward.org, and maybe they will be here next year. Nominations are evaluated by a very distinguished panel of scientists who comprise the Golden Goose Award Selection Committee, and then you see the fruits of their labors and yours. In addition to the founders whom Rush listed, the Golden Goose Award is supported by many, many other organizations and institutions that make this possible, without whose backing this evening and the award itself would not be possible. So on behalf of the founding organizations, I just want to thank these sponsors, do a little shout out for them, whose support has made this year's awards possible. So the Golden Goose Award Benefactor organization is Elsevier, which made a generous multi-year commitment in 2015. This year's partner organization is United for Medical Research, and this year's contributor organizations are the American Mathematical Society, the Association of American Medical Colleges, the Association of American Universities, Battelle, and Sage Publishing. And would you join me, please, in thanking them for making this possible? Now, we always have strong bipartisan support in Congress for these awards, and this year is no different. So we're pleased to have several of our congressional supporters here tonight. They broke away from the Hill where they were voting so they could be here with people who really appreciate them. And so it's my pleasure to introduce each one at a time, ask them to come up and say a few words. And again, to all of you, thank you so much for making the time in what is a very, very busy time for you to be here. So first, we'd like to welcome the newest Golden Goose Award congressional supporter and one of the central forces behind last year's American Innovation and Competitiveness Act. Please join me in welcoming Senator Cory Gardner from the great state of Colorado.
Thank you. Well, good evening. Thank you very much, and congratulations to all of you for the incredible recognition tonight. Colorado is an incredible home of great science, from our laboratories, our federal laboratories, to our great universities, to our private research through the business community that we have. It is magnificent to see what is happening, and I'm reminded tonight when I see and read about the incredible work, whether it's the fuzzy logic concepts of a shower head that's applied in Japan, or whether it's the frogs. By the way, our son and I conducted our own experiment. He's 5 years old. About a month ago, I was marching through a pond in Colorado collecting tadpoles, where we got to watch the entire cycle unfold before our son's eyes so that he could see how a tadpole turns into a frog and what happened when we took them back to the pond. Those moments where we can teach our kids, you do it each and every day. The incredible teaching moments that you have, the incredible breakthroughs that you witness to make our lives a better place. And whether it's science that has meant a motor that's half the size of a human hair, or science that shows us that we can freeze smoke and build incredibly strong structures that can be used for insulation, or the science that we're celebrating tonight. Science can happen in the places where you least expect it. But if we don't try, if we don't pursue it, we'll never find it. And to those of you who are in the scientific community tonight, thank you for going above and beyond each and every time to find it, to pursue it, to truly make a difference in our lives, because without you, where would America be? And if I could leave just one final thought in your mind to Congressman Cooper, where'd you go over here? Thank you for your visionary effort to make this happen tonight. To my colleagues in the House and the Senate, Chris Coons, where would America be if we didn't have people like those recipients tonight? The brightest minds from around the globe who come to this country. Why? Because this is where the big ideas happen. And may this country long and always be the place where those big ideas happen, that beacon of hope for so many people around the globe, the best and the brightest, right here at home. Let's always make science bipartisan. We can do it. We've got the power. Congratulations.
It sounds like a tweet to me, let's make science bipartisan. Now I'd like to welcome a Congresswoman from another great state. They're all great states, by the way. Oregon, who is one of the most senior Democrats on the House Science, Space, and Technology Committee, a founder of the Congressional STEAM Caucus, Representative Suzanne Bonamici. Sorry.
Thank you. Thank you so much. It's great to be back for another wonderful Golden Goose Award ceremony. I've been a supporter since I've been in Congress, and thank you, Representative Cooper, and all of my colleagues and all of you. Thank you and to our awardees, thank you for your scientific discoveries and for your creativity in addressing complex problems. Now, I am a member of the House Science, Space, and Technology Committee, and I'm proud to champion funding for federal research, and as demonstrated by the awardees, it takes vision and persistence to solve our world's complex problems. The federal government needs to be an active participant in this important work, and one critical part of that is funding research. And federal funding also supports programs that help us find new ways to engage young people in science, technology, engineering, and math, STEM, so that innovative companies like in my district, Intel, Nike, both major employers have the workforce they need to fill high-skilled, high-paying jobs. And I also serve on the Education and Workforce Committee, and I know that we need to educate students to be able to think creatively and communicate well and tell stories. And research shows that the benefit of integrating arts and design into STEM education, STEAM. STEAM education engages more students. It makes learning more engaging and relevant. Educating both halves of the brain results in more well-rounded students and more well-rounded scientists. So I'm the co-chair of the Bipartisan Congressional STEAM Caucus with my colleague, Representative Stefanik from New York. It is a bipartisan caucus, and we're working together to emphasize the importance of arts and design, broadly defined, in the education of students and the development of our workforce. And schools are now beginning to recognize the power of STEAM. There's a STEAM movement, in fact, in K-12 education and in colleges and universities, not only here in the United States, but around the world. They're encouraging students to approach problem solving, risk-taking, and creativity. In fact, the Every Student Succeeds Act, which we passed here with strong bipartisan support in 2015, includes our amendment to encourage school districts to integrate arts and design into STEM, and the House-passed Career and Technical Education Bill does as well. Now, looking around the room and looking at our wonderful awardees and knowing about them, we have some of the brightest mathematicians and scientists here, but I know we also have talented painters and musicians and poets. In fact, the Nobel Prize-winning scientists are much more likely than other scientists to be engaged in arts and crafts. Maintaining our position as an innovative country means continuing to fund groundbreaking research we are celebrating today and educating a cutting-edge next generation workforce able to take on those complex challenges through creative new ideas. And I'm committed to working with all of you to do just that. Congratulations to our award winners. Thank you for your work to illustrate the tremendous value of federal research, even research with silly-sounding titles. Thank you.
Thank you, Representative Bonamici. Well, next I'd like to introduce one of Ms. Bonamici's most senior colleagues on the other side of the aisle of the House Science, Space, and Technology Committee, co-founder of the House Science and National Labs Caucus, co-chair of the House STEM Education Caucus, Representative Randy Hultgren from the great state of Illinois.
It's great to be with you. Like my colleagues, I look forward to this night every single year. Jim, thank you. This is such a powerful night and so important for us to continue to champion research, especially government-funded research, and the discoveries that come from it to all of our those who are being recognized tonight. Congratulations. Thank you for your work. Thank you for your dedication. We're so proud of you and grateful for what you do. I love this night. I love looking at quotes and learning from quotes that can inspire me and others. Alfred North Whitehead, a British mathematician, said, "The silly question is the first intimation of some totally new development." Sometimes it's that silly question that sparks an idea of, well, maybe. Also, think of Isaac Asimov, science fiction author, great author, who said the most exciting phrase in science is not eureka, but that's funny. Love that. And then from the great scientist, you miss 100% of the shots you don't take. Wayne Gretzky said that one. But he's right, you know, and I think that is the message of tonight. We miss 100% of the shots we don't take, and we need to continue to take shots. We never know what we're going to discover, but I can guarantee you if we don't do this, if we don't invest in basic research, if we as a United States government aren't committed to this, we're going to miss 100% of those shots, and so we need to continue to be committed to this. I had the great privilege a little over a week ago to be out in Pasadena at the Jet Propulsion Lab at the grand finale of Cassini, an amazing probe to Saturn that achieved so far beyond what we ever expected it was going to do. It went up about 20 years ago, thinking it was going to be maybe a 3-4 year mission at Saturn. It ended up lasting over 13 years. Unbelievable pictures and research that was able to come from that, and to even at the very end to plan flying Cassini into the atmosphere of Saturn so it wouldn't hit the moons, do any other damage there, but to get results to the very last second. It was phenomenal to be there at Mission Control, very inspiring. And then I came back and got to meet with a group of students in my district. We started the STEM Scholars Program. This year we've got 27 high school students from the 7 counties I represent, where we're meeting every single month. We were just meeting together doing microbiology, studying staph infection and E. coli in stain experiments and things, just phenomenal things for us to be learning together. But what I see is this light bulb go on that for them, they're already interested in this, but usually it's like a specific focus, robotics, other things, engineering. But to see there's so many cool things that we can be doing in science, and that is what I believe this is all about, is certainly inspiring us, making sure we're doing our part, but also looking forward to next generations and seeing that we as a nation and we as a world are at our best when we're discovering and innovating. So congratulations, we're so proud of you. You have made a big difference, and we want to continue to support you and the great research you've done. Thank you all so much.
Congressman, thanks so much. I love the reference to the silly question. And Rush mentioned earlier I wrote a book. Well, the book is all about questions. It's called Ask More, and there's a chapter on science questions. And the other observation and contribution I would make to that is the other thing that is the part of the science question is it's the slow question. It's the question that reveals over time, maybe a whole lifetime, and it holds such magic as a result. So, I'm pleased to welcome Congress's only physicist and steadfast champion for such questions, federal investment in scientific research and STEM education. So please join me in welcoming, also from the great state of Illinois, Congressman Bill Foster.
Well, good evening, and thank you so much for being able to come out here tonight and support and honor the effort and success of these great scientists. I want to reiterate a special thank you to my colleague, Congressman Cooper, for having the inspiration to start this initiative. Although not a scientist himself, Jim Cooper understands the importance of science to our economy and our national security. And more importantly, not only does he speak out in favor of science, he actually votes for budgets and appropriations that support those investments. If we had a lot more like Jim Cooper in the U.S. Congress, the scientific enterprise would be... The scientific enterprise would not be under the stress that it is today. Now, for those of you who don't know me, I'm Congressman Bill Foster. I represent the 11th District of Illinois, but before coming to Congress, I was a high-energy particle physicist for 23 years at Fermi National Accelerator Laboratory, where I was part of the team that discovered the top quark, the heaviest known form of matter, and later invented and led the team that built the magnets for the Fermilab antiproton recycler ring, the latest of the giant accelerators at Fermilab. So I sometimes introduce myself as representing 100% of the strategic reserve of physicists in the United States Congress. But before that, when I was 19 years old, my younger brother and I started a high-tech company in our basement with $500 from my parents using this brand new invention called the microprocessor. And that thing that we started using the knowledge I gained as a physics undergraduate and now that company provides about 70% of all the theater lighting in the United States, including, if I'm not mistaken, I think the lights in this building and the computer system. Is that right? I guess so. Thank you, Solomon. It always pays to be friends with the guy who's running the lights but that background is really one of the many reasons that I'm always excited to come to this event every year, because I know firsthand the value that research and development has on our profession, as well as the threats of anti-scientific attitudes in Congress and that they pose to the future of our nation. You know, there have always been skeptics and science deniers in the Congress and in the population of every country. But in recent Congresses, we have seen a membership that has grown more and more partisan and often antagonistic to facts and logic. Curiosity-driven research in particular has come under increasing threat, and I worry about what that trend means to young researchers who are just starting their careers. And the Golden Goose Award is a perfect opportunity to remind everyone why federally funded research is so important. Every year, the award concentrates on a few stellar examples of the enormous return on investment from the home runs in federally funded research, and that's a wonderful and good thing to do. But we should not forget the enormous contributions of cross-cutting and often off-label applications of technology in areas that were never mentioned in the grant proposals, and of researchers that are trained in one area of science and then use that expertise to cross-fertilize an entirely different area of technology. For example, how many of you know that some of the technology at the core of RFID tags that are revolutionizing logistics were actually partly developed as a byproduct of federal research in quantum computing? You know, that sort of list could go on all night, and that's why it's important that as we gather here tonight to celebrate the easy-to-document home runs in federally funded research, that we should never forget the much larger number of undocumented cross-connections in science and technology that make our scientific enterprise the envy of the world. And thanks to everyone that made this possible.
Wait.
I'm now instructed to yield the microphone to Congressman Paul Tonko, my colleague on the Science Committee, who represents a significant percentage of the engineering experience in the U.S. Congress.
Thank you, Bill, and good evening, everyone. What a powerful moment to join with all of you as we showcase exemplary action out there and inspiration that is provided through the vision that you bring to all of your experimentation and all of your discovery and the excitement that prevails. It is powerful. So thank you again to Jim Cooper. I know you've been mentioned time and time again, but to provide that vision so that we can have these moments of recognition are indeed going to build a stronger and more responsive nation. So thank you, Jim, and thank you to my former colleague, Rush Holt, who I see in the front row, who has landed in a perfect location because he has such an interest and love for science and technology, and to be able to advance science from his perspective is great for all of us. So thank you, Rush, for the continued contribution to the growth of this country. You've heard from my colleagues. It's great to be with you this evening. I'm an engineer who found myself serving in elected office, and so believe wholeheartedly in STEM and STEAM to promote the future so that a career path is chosen by many of our young, because we woefully underproduce the technicians, the scientists, the engineers, the mathematicians that our society requires. And so moments like this remind you of the value added that all of the professionals in that capacity bring to the quality of life, not only of our country, but around the world. I represent an area that is deemed to be one of the fastest growing for clean energy, high-tech, innovative jobs in an Erie Canal corridor that perhaps was the first technology corridor in our country that sparked a westward movement and that drove a spirit through a necklace of communities dubbed mill towns, this awesomeness of invention and innovation. They were the epicenters of such activity. And so tonight, it's good to see this new realm, the generations of discovery that continue to follow, and pay honor to the pioneer spirit of this nation. You're looking at someone who was impacted by the global race on space. It drew my attention to politics, and it probably developed my career path to engineering. Because if we were going to land that American on the moon before any other, it was going to take great invention, technology, and a reliance on science. And so I respected those arenas and became a part of it and realized that politics indeed can cause magical moments and golden opportunities. And so I have been driven to continue that effort through the halls of Congress. I have probably, for an engineer, the two wonkiest assignments to make me happy: energy and commerce as a committee assignment, and science, space, and technology. But what do I hear in the halls of government? Too much science denial. So it's driven me to author the Scientific Integrity Act, and I would ask that we all pay attention to that so that we do not mess with federally funded research, that we offer the honest results, we do not suppress it, we do not misrepresent or mischaracterize it. And so we're warmly inviting those participants on either side of the political fence to join us in making that message resoundingly clear. We cherish science, we embrace it, we understand we grow with science, and that is a very important element of the work that needs to be done. Finally, it's just realizing that if we're going to compete effectively in this global race on clean energy, high tech, and innovation, as we did in the previous global race on space, we need definitely to have that workforce and to drive, again, the research that will offer the new prototypes and product lines that will, again, enable us to be the champion of this activity in the world economy. So thank you, everyone, for providing that moment of magical discovery and recognition that should inspire all of us who are policymakers and budget resource advocates to do our very best job and to respect science along the way. Thank you, everyone.
Okay, you have your warm invitation on behalf of the integrity of science. Well, finally, everybody's been talking about this guy. We need to get him up here. I'd like to introduce the man that we fondly refer to as Father Goose. Representative Jim Cooper of the great state of Tennessee, as a young member of Congress, he couldn't understand why Senator Bill Proxmire, some of you may remember him, and some of you may remember his Golden Fleece Award, why Senator Bill Proxmire would confer a Golden Fleece Award for wasteful federal spending on scientific research. He thought we should honor scientists, not ridicule them and their work. So he urged the founding organizations to create a Golden Goose Award. And it's thanks to his vision and his persistence that the Golden Goose Award is now in its 6th year, celebrating remarkable scientists who've made remarkable contributions. Please join me in giving a warm welcome to Congressman Father Goose, Jim Cooper.
Thank you. Thank you so much, Frank, Russ, my colleagues especially. Thanks to each one of you for your terrific work. You know, I don't deserve a fraction of the credit that's been given to me tonight, but hey, this is Washington. I'm going to claim it anyway. You know, you're in a funny place tonight. This is Washington, D.C., and this is Hollywood for ugly people. So you haven't heard that before? Come on. This also makes tonight kind of like Oscars night. But if you're not in black tie or a ball gown, that's okay. We're going to celebrate good science anyway. And that's what every American, every citizen of this planet should be doing. There are so many things that we need to cherish, and a lot of talk has been about storytelling, but this phrase should stick in your mind. Tell me a fact, and I'll try to memorize it. Tell me the truth, and I'll believe. But tell me a story, and I will carry it in my heart forever. All of us, especially if we want better federal funding, and if we want to protect ourselves from political ridicule, we need to be good at telling stories. And there's so many fabulous stories to tell. We need to celebrate ourselves, celebrate our profession, celebrate science, celebrate discovery, celebrate the best hope for the future of this planet, and get all elected officials to believe. I saw this the other day from the ancient scientist Alexander von Humboldt, who said there are 3 stages of scientific development. One is all the experts say it's not true. 2, all the experts say, well, if it's true, it's not important. And 3, all the experts attribute the discovery to the wrong person. Well, we here in Washington have added a 4th level to that. Politicians will try to make fun of the discovery, and that is a shame. Let's not set back science, let's move science forward, and that's what the Golden Goose does. Thanks.
Bravo, bravo. Well, before we move on to the next part of the evening, just a couple of shout outs. First, I'd like to recognize Maria Zuber, chair of the National Science Board. Maria, if we could have lights. Maria, would you please stand? Maria, thank you for speaking so eloquently today at the VIP luncheon with the awardees. We have quite a few folks here who came all the way from the West Coast. So stand up if you flew across the country to join us tonight. All right, this is a good thing. All right, so since, what is the Oscars, what did we call this? Okay, so someone is sitting on or near a prize. Okay, you're not sitting on a golden goose or egg or anything like that. But one of you is a prize winner. If you look under your seats or feel under your seats, you'll see a card. I get to watch everybody goes rummaging under their seats. You'll see a card. Anybody got it? Not every seat is full, so if not, I'll give a hint. If there's an empty seat next to you, anybody got it? Especially in row J. Especially around the 100 numbers. You got it, all right. Congratulations. You will get a professional photograph together with the awardees this evening after the ceremony. So, and maybe you can take a story on that home with you. All right, so now for another Golden Goose tradition, our wonderful documentary video. This will tell you several stories. It'll introduce you to the 2017 Golden Goose awardees, a number of the organizations who make this video possible included, and I'd like to give particular thanks to American Society for Engineering Education and Vanderbilt University for their support. Please enjoy the film.
Like the fabled goose that laid the golden egg, federally funded scientific research has yielded extraordinary yet unexpected returns.
Out of odd-sounding, obscure beginnings have come many amazing advances that have improved each of our lives.
The Golden Goose Award recognizes the people and the stories behind these unexpected and incredible scientific breakthroughs.
I finally decided to use the word fuzzy, meaning unsharp. But I knew very well that it's the kind of word that will give some trouble. And indeed, it did.
Most people think that if you write down a mathematical formula, it's either true or false. And in Latvi's paper, he said, no, that's not necessarily the case.
People started understanding that what people want out of objects that they interact with in everyday life, be they subway trains or rice cookers or cameras, are really not expressed in numerical terms.
The basic premise was different. It was fuzzy, it wasn't 0, 1, but it was all the numbers in between 0, 1.
So imagine you want to have a concept like a tall man. We would all agree that someone who's 4 feet tall is short, and we would all agree that someone who's 8 feet tall is tall. But what about someone who's 6 feet tall? That's not necessarily either true or false, 0 or 1. And so that's what's called fuzzy. Something is not exactly true or false. Now, once you get away from zeros and ones, then all the rules of logic that we've used since Aristotle go away.
How you get those distributions was the profound difference between what Latvi perceived and what the rest of the statistical community believed and still believes.
Senator Proxmire, he was going to give me Golden Fleece Award. This award was given to people and receiving taxpayer support for something that didn't make any sense. So I finally persuaded Senator Proxmire not to give this award to me, but this was pretty close.
Some of the backlash is, I think, really the method of science. When there is a change in paradigm, there is resistance, there is animated debate.
He really was in odds with all the mathematically minded people who said, well, why do you need this new measure when you have a standard probability theory.
I think the big breakthrough came out in consumer electronics.
Your braking system, your washing machine, consumer devices, you name it, they all have this kind of logic built in to help interact with the users.
The federal research that went into lottery thinking about fuzzy logic has spawned a gigantic industry, has spawned a gigantic academic community.
And now, of course, AI is in another, golden era when everybody is, asking themselves, or is everything going to change because of that? And Latvia was one of the early pioneers in that.
You really cannot predict what the discovery will be 5 to 10 years. And that is the critical thing.
And I think in terms of an ROI, it is really quite spectacular.
Looks like a peanut butter. So this will be the fun part of today.
Unless you've seen a hardwood plywood panel, you probably wouldn't recognize one. What you do recognize, though, are cabinet doors, the sides of cabinets, the sides of furniture. All that is quite often hardwood plywood, just converted into a finished good.
Formaldehyde was becoming a bigger and bigger issue. It was just showing up in more studies, more cancer studies. This was presented as a solution that could replace all of the formaldehyde-based adhesives in our company.
So you look at all this, they just stick there so strongly. I don't think I can get this one up. A friend of mine said, let me show you the Bay Area. There's lots of muscle. You drove down here and show me this place. As you can see, that all the muscles stick together. Really thick layer of muscles stick together. As a chemist, I always say, this is amazing. How can they develop something that can stick to the dirty, wet surface? So I went back to check the literature. It figured, somebody who did down the research and said, oh, they figured out this muscle produce a protein, had this unique, it's a unique amino acid composition. How can I utilize this extraordinary ability to develop adhesive? Then one day I was eating lunch. I suddenly realized that soy meal has about 50% protein. Now protein is protein. They all consist of amino acid, but it has different composition. So at that time I thought, can I convert the soy protein into excellent adhesive this way? That's how we got started. That's how we got the funding from the USDA. It was a long process. We published more than 30 papers. We found that use a Western agent, just mix it with soil and water. And during making the plywood, it made the adhesive very water resistant. I gave a presentation and I basically described this novel adhesive system.
And after the presentation, I couldn't help but think he was talking directly to us, directly to our company, because this is what we'd been looking for years. So we struck up a conversation immediately after that meeting. And before we left that conference, we had already settled on an agreement to pursue commercialization with them. We worked in the lab for a while just to get an understanding of what we think it's going to take it to one of our factories and try it. We had built a portable mixing system, and that went on for probably 3-4 months. And we went to the factory the first time, and it was a disaster. Nothing worked. But it was a learning experience. It was the first, so we looked at all the things that didn't work well. We take that back to the lab, and we work on it again, and we come back to the mill again.
We started converting our mills in 2005. Now we estimate that over 60% of all plywood made in America uses a soy-based resin as its bonding agent.
It had so many benefits that were beyond just the product. We could provide a better work environment for the employees, a better community environment around our mills, and provide our customers with a product that's healthier as well.
I enjoy what I did, so I enjoy working. But I never thought it has such a big impact.
The impact is really, really big from this kind of work, and those federal dollars come in and they provide the seed money and actually let it grow more and more and more to be something where then everyone says, boy, we needed that and we didn't even know it could exist.
We started to see this organism within the skin, and we weren't really sure what it was. The populations crashed so rapidly and so dramatically. You have the potential to lose entire wildlife species. Losing that diversity, I just think the world becomes literally a less colorful place.
The outbreak started in the fall of '96.
We started to have deaths of these blue poison dart frogs within the collection.
Had this very distinctive skin disease. It appeared to be caused by some microscopic organisms. They looked like they were probably organisms that are called chytridiomycetes. And there weren't too many people in the whole world that were experts on chytridiomycetes.
I've been here since about 1985. I was a full-time stay-at-home mother. An NSF grant got me back into chytrid work. As a child, we lived on a farm. My favorite activities were going down to the creek and catching fish. Finding chytrids is like going fishing.
She was one of maybe 3 people in the world who could really tell you what kind of organism this was, and one of the few people who really cared, I think, about this group of organisms.
At the National Zoo in Washington, D.C., the poison dart frogs started to die. If something dies at a zoo, you have to find out why. They knew if I could isolate disease from the frogs, that was a way to diagnose that's what these frogs had. It was a Sunday, I think I came in, and I looked at that bottle, and I said, either there's bacteria growing in there or that fungus has grown. I found one of the most exciting things I could think about. This seemed to be a new disease of amphibians.
She contacted us quite excited and said, yeah, this is something new. This could be kind of a big deal.
But it wasn't just happening here, it was happening all over the world. There were populations in the wild that were mysteriously disappearing.
Coming to Panama for the first time, there were so many frogs. The noise is crazy out in the forest. Comparing that at a site where the chytrid had hit, the comparative quiet, is devastating because the thrill I get from picking up these frogs and playing with toads that I've had from when I was really small, to imagine that there are going to be other kids that don't have that opportunity makes me really sad.
I grew up in a rural area. I would just spend hours playing in the creek and catching frogs, catching tadpoles.
I've always liked the creepy crawly kind of things. Biodiversity, it's a big jigsaw puzzle. Lose a piece of the puzzle, the picture's not whole anymore.
We humans are stewards of the earth. It's important for us to maintain biodiversity in these rich and different environments, mostly because we don't even understand it ourselves. We don't know what secrets are out there.
The story of Joyce Longcore working away just for science's sake. Overnight, she goes from just this into a scientific rock star and making this really important contribution to saving amphibian species globally.
I was content to study a group nobody has much interest in. I still am content to do that work.
Without federal funding, we never would have been able to do any of this.
Science begins and happens because of federal funding. Not only does it allow us to answer difficult questions that the private sector might ignore, but it also allows us to do so for a long period of time.
Federal funding is the baseline for so many research projects. If we have that baseline project getting started with federal funding, we can add on all the parts that make it into this big, likely successful research initiative that can take years or decades to complete or to see the fruits of that labor.
A fundamental national strength is our ability to really invest across several fields rather than investing in specific outcomes.
Research often begins with just curiosity.
The return to investment for the American taxpayer has been gigantic.
Some of it will just be beautiful, pure science and pure mathematics, but if you don't make that an investment, then huge payoffs may not occur.
You never know when something that is found will become important.
What'd you think? Pretty good stories? Pretty amazing science? I have to tell you one thing, all right? There's been all this talk about story. This film knocked it out of the park. Here's why. Basically, I tell my students, a story, its guts are really pretty simple. Compelling characters, overcoming obstacles to achieve a worthy outcome. And that's what you just saw. Compelling characters, overcoming all these obstacles to achieve their worthy outcome of discovery and the improvement of human life. So bravo to you and bravo to the film. So, without further ado, let's bring them up. Our 2017 awardees and present them with their Golden Goose Awards. So first I'm going to invite some special guests up here because they're going to be with a welcoming committee and the reinforcing committee, and they'll help us present the awards. They're from the 4 agencies that funded the amazing work that we highlight tonight. So please join me if I can invite you up one at a time. John Davis, Provost of the Smithsonian. Federica D'Arima, Director of the Air Force Office of Scientific Research. Joan Fernimundi, Chief Operating Officer of the National Science Foundation. And Sunny Ramaswamy, Director of the National Institute of Food and Agriculture at the U.S. Department of Agriculture. So thank you. On behalf of everyone in the room, please keep doing exactly what you've been doing. The first recipients, and I'm going to ask them to come up one at a time, of the 2017 Golden Goose Award are from the intrepid team who discovered the importance and the use of this fungi that we know so well, and frogs. So first, Joyce Loncourt. Go over there. Elaine Lamarand. Don Nichols. Congratulations. and Alan Pessier. Congratulations. Now to the muscle man. To Kai-Chang Lee, who was inspired by muscles to pursue an incredible opportunity to patent this soy-based adhesive for plywood that's dramatically changed the industry and taken the formaldehyde out. Congratulations. Is this just the coolest thing, the Academy Awards for Science? I mean, I'm loving this. This is awesome. And finally, our final awardee is the late Lotfi Zadeh, whom you saw up there, whom we lost just a few weeks ago. He proposed this revolutionary concept of fuzzy logic in 1965 to deal with the mathematics and the logic of imprecise information. As I mentioned, sadly, and as you saw, he passed away just a few weeks ago at the age of 96. He was working almost until the end. We have a picture of him on stage. We wish he could be with us to celebrate his accomplishments. Accepting the award on his behalf is his former colleague, David Culler, professor of electrical engineering and computer sciences and interim dean of the Division of Data Sciences at the University of California, Berkeley. Would you join me in thanking the presenters? And we're going to ask you all to please take your seat and join us for the conversation now, which I'm going to have with the winners. Thank you, and congratulations again. Please have a seat. You're all movie stars now.
Right.
That's not a bad thing. We'll get you an agent, we'll sign contracts, and keep your research going forever.
Facelift.
Facelift. You see, compelling characters. I knew that was going to happen. Kai-Chang, there you are. So compelling characters overcoming. There were a lot of obstacles, right? And we heard from your commercial partner there that a lot of stuff just didn't work out. So what happened? What went wrong?
Well, we didn't really understand this new thing. So we're talking about the invention from 0 to 1, not from 1 to n in development. So when we apply our adhesive for commercial production, they always thought, oh, we had to use the viscosity had to be this low because they get the knowledge from the old toxic urea formaldehyde adhesive. So they already have mindsets. You had to use this.
So they were
way.
trying to use the new stuff the way they used the old stuff.
Yeah, exactly. The same way they say you had to use it. The viscosity had to be the ballpark of the old adhesive. But of course it doesn't work because it looks like a peanut butter. But
how do
it
you
turned
put
out,
peanut butter between
but there's a science behind it. Is that this is called shear thinning. The faster you mix it, the thinner it becomes. So the answer is simple. You just stamp it to the ruler, like a ruler coater. Once the ruler coater is rotating, it coated very well.
Uh-huh.
So you don't need to really get the low viscosity that like an old glue has.
How did you figure out the formula for this? I mean, we talked about sort of discovery. Did you have any aha moments that revealed this, or that you were onto something big?
Well, actually, we were playing around with this muscle glue. It really wonderful. It stick to whatever you can get. They just stick there very well. But the problem is that it produces very tiny. You're talking about milligram scale, a gram scale. But for the wood industry, you're talking about hundreds of millions of pounds every year for each private plant. So we made a discovery, published paper. There's really basic science. We have new adhesion theory of why this thing work. But then it's too expensive. So one day I was eating lunch, eating tofu. I suddenly realized that I'm eating protein, same protein.
Protein.
Yeah, exactly. The protein.
And you were eating healthy too. That's a good thing.
Exactly. Yeah, I mean, they're both protein, but they have different composition, different amino acids. So.
Will it upset you if I tell you that we're going to have mussels upstairs?
Really? Yeah, it tastes good. I mean, really good. Really good.
Why were you out foraging for mussels that fateful day? What were you doing?
Well, we just have, at that time, we didn't have kids, so we go out to the coast to spend a weekend crabbing. So one of my friends, at that day, we weren't very lucky, so we didn't get any. So a friend of mine said, we just cannot go home empty-handed. So I said, what should we do? And she said, well, let's get some mussel. He should show me the Bay Area with shoot the film. I saw all the mussels stick together so strongly. I was amazed. The first time I saw the mussel stick to rock so well. But typically, when you want to glue something together, first thing you need to do, you clean the surface, right? When the surface is dirty, it doesn't stick. And when it's wet, it doesn't stick. But mussel has this unique ability, they stick to the wet and dirty surface. That was really amazing. So I had to get a piece of wood and pry it out. I mean, it was really hard to get it out.
Could you have ever imagined, did you ever imagine that you would contribute to a contribution as significant as removing formaldehyde, what had been a killer thing from this kind of production, that you could make this kind of contribution through a discovery like this?
No, I didn't really thought about it. I mean, we just like to have fun. I thought, okay, when I was a postdoc at University of Georgia, my advisor was from Sweden. Now he already passed away. One day at that time, somebody published a paper, say use enzyme to glue wood together. Say you don't need any toxic glue. So I asked him, say, what's the big deal of this discovery? Wow, he said, wow, you look at my face, you think my face is red? I said, yeah. I mean, he's Sweden, she's from Sweden. Right? So I said, but he said, you really look at those people working in the private plant in 1950s. He said, all those, because formaldehyde is a skin irritation, so he said, oh, you never like to work in that kind of environment. So this is the first time I saw, oh, formaldehyde is bad. I mean, some people still argue that it's not bad. I mean, still some of my colleagues still said formaldehyde is nothing. So I said, at least it's not very nice chemical. But to me, this like something, invent something to improve our living environment. That's pretty good.
Yeah, it's pretty good.
Yeah.
Don, I'm told that you'd seen this chytrid thing before the outbreak at the zoo, and you'd been on this for a while. Where'd that all come from?
Well, right after graduating from veterinary school, I did a residency in veterinary pathology at the National Zoo. And then when that was over with, I had to go find a real job. So I ended up at NIH, but my heart was really in the zoo animal stuff, and exotic pets, that kind of thing. So I had a moonlighting business, which I got approved by NIH, where people would send me samples from animals that, because most zoos don't have pathologists. I mean, there's only, like, what, six? Yeah. So I got some samples, some dead toads from a research colony at the University of California, Santa Barbara, where I'm not sure what the researcher was doing, but there was over 100 toads in this colony, and over half of them had died.
Half of them had died?
Yeah. And they couldn't figure out what was going on, so they put some toads in formaldehyde and mailed them to me. Yeah.
He rests his case. Did not bring them back to life, but go ahead.
So this was 1991, and I saw this unusual skin disease and these associated with these microscopic organisms that I had never seen before. And I was pretty sure I hadn't seen any publications about it either, because I was pretty up on the published literature on amphibian diseases. Yeah. And so they looked like they were maybe protozoa, some kind of parasite. So I took samples to the Armed Forces Institute of Pathology, which was at the Walter Reed complex, and showed them to a parasitologist there. And he said, well, let's do some other stains and let's do some electron microscopy, which was nice because I didn't have to pay for this. This was all, it's the Department of Defense that funded that one. And he said, no, they're not protozoa. They're probably either algae or fungi. So then I took him to an algae expert at the Museum of Natural History and showed him to her, the Smithsonian. And she said, no, they're not algae. They're probably either fungi or protozoa. So then I said, well, they must be some kind of fungi. And then I went to the National Library of Medicine on the NIH campus and went through textbooks of what fungi looked like by electron microscopy. And I couldn't get them to match anything in the textbooks that I was looking at. And then by this time, I had gotten a position as a staff pathologist at the zoo. It was my dream job, yay. And
a real job.
Yeah, it was a real job, but it was better. Well, anyway. So I decided to look through the zoo's pathology records to see if I could find any cases of it there, and I did. I found 3 cases, one from 1988, one from January 1990, and one from later in 1990. So I went and I retrieved the samples we had, the tissue samples that we had stored, and I did the same special stains, the same electron microscopy. They looked the same, but I still didn't know what they were. But I reasoned that if it had occurred at the zoo's collection on 3 different occasions, that maybe it would pop up again. So for the next 5 years, whenever any amphibian died, I would tell the residents doing the post-mortem exams to take lots of samples of skin because I was looking for something. If they asked me what, I said, oh, I don't know, but I don't know what it is, but I know it when I see it. So anyway, the fall of 1996 is when the outbreak started at the zoos, and that means that we lost 32 frogs over a period of several months. So once we knew we had an outbreak going on, it gave us an opportunity to get really good samples for electron microscopy.
You were a detective.
Yeah.
I mean,
yeah,
it was serious detective work, propelled by your science. So when you got involved, Alan, you thought it was frogs, and you were dealing with the frogs, but then you learned or you discovered it was much bigger.
Well, certainly we thought this was a cool disease in zoo frogs. And
Disease?
Well, pathologists, So
I'm up here with pathologists and formaldehyde people. I mean,
if I say anything like that, it's just, yeah.
We get it. It's okay.
Yeah. My mom calls me a dead animal doctor, so. But, yeah, certainly. So we, and we had, at this point we had the collaboration with Joyce, and we had it nailed down that we had a chytrid, and right about that time a keeper shows up with a copy of the New York Times and a picture of the chytrid in the New York Times, photomicrograph, and the chytrid fungus is very distinctive looking. We knew right away what it was, but the article said it was a protozoan, so we got pretty excited. So because we knew what it was. It was this really cool moment, actually.
And so that was your aha moment.
It was certainly, one of my big aha moments was that.
And so when was going through, when your aha moment, after you said aha, then what did you say?
Well, it's a chance to really help the frogs, I think, a chance to really contribute this identification and this other thing. So, yeah, it was an amazing moment. Just had that moment of just knowing something that,
Elaine, how did you get involved in working with these zoo animals and these guys?
Well, I got involved at the zoo because I grew up in the area, so I was born in D.C., grew up in the area, and my Aunt Judy, she had volunteered at the zoo, and she still does volunteer at the zoo. So when we were little, she would take us to the zoo.
Is Aunt Judy here?
She's not here today.
Oh, because I know you have family here.
Yeah, I have a whole bunch of family and friends here. So she would take us to the zoo, and she'd introduce us to people that were doing cool things. So that's when I decided, this is, you can make a living doing something fun. So that's where I wanted to be.
And from there, you went into this how?
So I eventually worked my way up to getting a research position for a while at the zoo, and then I had to leave and go to NIH, and I happened to go to Don's lab, and that's where we met.
And fruit flies came into this thing somehow, right?
Fruit flies came into it a little later. So once we had the organism isolated and we started doing frog experiments, we needed frogs in order to do the studies.
Yeah.
So luckily we had the Amazonia exhibit, and our friend Ed, who can grow just about anything. And so we needed a bunch of frogs. So in order to have a bunch of frogs, you need a bunch of food to give to the frogs. So we worked out a deal where we provided more jars to grow fruit flies, and then I would go down to Amazonia and help out with the fruit fly cultures and getting that up
So
and going.
you were the fruit fly expert, among other things.
Yes.
Yeah, I see.
Yeah.
And that was part of the deal I struck with, because I realized all of the frogs that had died at the zoo had been at the reptile house, but we had a colony of dart frogs at the Amazonia exhibit. And as Elaine said, Ed Smith could get these dart frogs to breed pretty readily. So I knew I had a source of clean frogs that we could then do experiments with. So I talked to Ed, and Ed was on board with helping us out. But he said, you got to talk to the head of the exhibit, the curator. So I went to him, and he said, well, okay, I'll be on board with it if you give me some extra mason jars to grow fruit flies in. And I could get those.
A little horse trading here, right?
Yeah, and I'm going to put in an ad. I could get those wholesale from my father's hardware store. So that's not a problem. And he said, and I also need, how about letting Elaine come down to the Amazonia and work with the fruit flies, so, So then I had to go to Elaine and say, you want to go work with, spend a couple hours a week growing fruit flies. And so I cobbled it together.
Joyce, I was struck in the film by your probably less than traditional path to scientific greatness and your golden goose here. You said you were a stay-at-home mom, and an NSF grant brought you back into the lab. Talk about that and what that was all about.
My husband is a wildlife biologist, and he had a field job, and he tended to be out of town quite a bit. So, and I was not a person to be able to manage taking kids to daycare and doing this and doing that, so I stayed home. But the kids were growing up, and I knew I had to do something so I wasn't over-minding their business. So one day, a woman by the name of Joan Brooks came and knocked on the door and said she had an NSF grant to study the microbes in a domestic sewage system. If you're not on a sewer line, you have a leach field. Hers had failed, and instead of replacing it with a traditional leach field, she replaced it with peat. Peat that grows, sphagnum peat that grows in the bog. Okay, so she was studying the bacteria and all the fungi, including the aquatic fungi, and it was too much. And so she said, will you come and help me? She knew from a person on her committee that had overlapped with me at the University of Michigan that 20 years previously to that, I had studied chytrids. She convinced me I still knew more about them than she did.
And she convinced you that given a choice between you driving your kids around in a septic system, you'd much rather be in a septic.
I'd much rather deal with the samples from the septic system.
And you've shared this with your children, I'm sure.
I don't know.
There they are.
Okay, so once I got back behind the microscope, I had forgotten about all this stuff for some 20 years, I got back behind the microscope. Oh, yes, this is what I do. And
it felt great.
Well, yes, great enough that I was willing to go back to graduate school to get a PhD in my late 40s, early 50s. That includes biochemistry and physics and a few things. You just try. But
it's easier in your 40s and 50s.
Oh,
right?
yes, yes. But I did. And okay, so I thought, all right, now I have my degree and I'm getting to be a specialist in chytrids. I'll get myself my own NSF grant. That did not happen. So I sat in the corner of a lab and did my research and published papers on chytrids until the zoo got in touch with me. And from then on, it was Alan and Don and Elaine. And I remember when it happened, they sent me the electron photomicrographs.
Yeah.
And I had been studying the electron microscopy of different chytrids. And so I knew what the cross-section of the reproductive zoospore looked like under electron microscopy. And there it was, laid right out in front of me, exactly what I'd been seeing from pure cultures.
So how does it feel as you think about your pivot in life, your PhD, and teaming up with the zoo folks here to have had the kind of impact that you've had?
Satisfying.
Good.
It is. It's always satisfying to help do something that helps other people with their research. And I've been able to do that because because of my culturing work, I had a lot of different isolates of the fungus and culture, and people from all over the world have requested them for research on this disease.
And one last question before I move on. You work with young researchers and women researchers now?
I do when I can.
And what do you tell them? Because you had a big juggling act in life.
Okay, so I do not teach. I don't have a job. I've not had a job.
Be careful,
But whenever people ask me to speak or I have undergrad technicians, I always make sure to tell them that I didn't get my PhD until I was in my 50s, that there's a lot of time after you're 50 left to do interesting things. And that don't worry, you can change, you can do something else. And it's, as I say, it's satisfying.
That's great, just great. David, can you talk to us? And Latvia's there, picture of him, amazing life, amazing contribution, fuzzy logic. Can you talk to us a little bit about the man?
Sure. It's an honor to be here next to Lofty. He would so enjoy being here. Clearly he was a person, he enjoyed the notoriety. He enjoyed being a little provocative.
Yeah.
But in that deep sense of, causing you to question. And he had a great sense of humor. And, he received a lot of criticism, to which he explained this to young faculty. His response was, I will take that as a compliment. And clear into his 90s.
It didn't get him down?
Quite the opposite. He, clear into his 90s, he held roundtables. He brought people together from the round and just longed for this engagement of ideas. And at some level, deep inside that criticism, that showed you had given his work enough respect to think hard about it. So he also loved to give advice. So as a chair, early young chair, he slept in my office, and he had many lovely sayings, maybe based on that experience. He said, friends, they come and go. Enemies, they accumulate.
Being that we're in Washington, we would not be able to relate to that anyway, right?
This was good guidance. So he's a wonderful case of this, trained as a classic, math and physics and pioneering work at the days where electronics and computing was coming, the Z-transform and linear systems theory. But these were heady times in the late 50s, early 60s, and thinking about machines, computational machines that would embody understanding. And the stories of, apparently he was thinking about this. You go on a walk to get lunch, and, isn't that a nice sports car? So why is that a sports car? What about that sedan? And so this notion that how you categorize things, he was so captured that we as human beings so basically work with understanding the ambiguity, the fuzziness, and none of our mathematical foundations can express that.
Was he a compelling person to be around, and when he conducted these roundtables, was he spellbinding?
He was jovial. He would sit back. He was much more of a convener, a facilitator, but he would welcome a diversity of ideas.
And how has his work been recognized in the scientific community?
Well, of course, to this day, it remains a little controversial. And at the same time, throughout the world, also incredibly recognized. So his original paper from '65, which is a small little, I guess, 90,000 citations. He's in our National Academy, but he's in 5 other national academies, since. And it's amazing, from that time, he really dedicated himself for 50 years. And of course, he's won more than 50 grand awards, one a year for a lot of years, I guess. It's amazing to see the outpouring. I mean, we held his 80th birthday celebration, and we had presidents from universities around the world, and at some point, there was kind of a bustle, and 3 of them went off to the restroom, and they came back in their formal garb and presented him with 3 honorary PhDs.
Wow.
He had 26 honorary PhDs in mechanical engineering and electrical engineering and computer science. So it's an interesting mix of the achievement and at the same time, things that he would take as a compliment.
Rush to the point of story. Everyone a compelling character, everyone overcoming obstacles, everyone trying to achieve that worthy outcome. I'm from the television business, so I'm really good at wrapping up on time, and I've been given my cue. I'm also really good, because we need to go and eat mussels and not drink formaldehyde. But I think we'd be remiss if I didn't ask each of you, in good, we're wrapping up here, brief form, to offer your thoughts about the importance of federal funding for this kind of work that you do. We've heard from the members of Congress and others, but you're in the front lines of this. So Don, very quickly, you just want to just give us a line on the difference this has made for you?
Well, I mean, I'm kind of in a unique situation in that I was employed by the Smithsonian, which is federally funded. And, if I wasn't employed, I wouldn't have done this.
Like, I didn't have a real job.
Yeah.
Enough said.
Yeah. No. I grew up in the area, so I'm used to working for the federal government. Lots of my family works for the federal government. Doing science for the federal government, it's pretty much all I've done.
Wouldn't happen without it, no?
I think that if you don't have mechanisms in place where these kinds of discoveries can be made, or just, people would say, why would you look at a dead frog? But having that specialized sort of resources available at Smithsonian at the time and others, we wouldn't have been in the right place at the right time to find what was needed. So
Wouldn't have happened if it hadn't been for the grant, right?
Yes. But continuing federal funding for our group, the frog chytrid opened up research in the chytrids in general, the chytridiomycota, and still there has been a lot of NSF funding for study in this group in the past, and it has made a big difference in what we know about the group.
Yeah, I think this federal funding is really critical from my own experience. If there were no like a USDA, NI, National Research Initiative competitive program, I wouldn't get the funding. But now the policy is shifting to give a big grant, like a $28 million a piece, but they eliminate those small competitive grants. To be honest with you, I only get $87,000 for the grant.
So we need those small grants.
Yeah,
too.
we need those small grants so inspire, so people have some seemingly crazy idea, they can explore it. But I would say if without the small grant, there wouldn't be any formata if we would have hit it, to be honest with you. But now, if you say only awarded a few, $20 million grant, big one, so then you are missing out a big pool of scientists who have crazy idea, good idea. They don't get any chance of getting funding.
Sure. David, you get the last word.
So I would encourage many of us, if you haven't read it lately, go back to Vannevar Bush and that 1946 memo and translating, the tremendous effort that went into war, into peace. And, we really, it's hard to imagine how much it can change the world. So if I could share a little personal story, some may remember there's a picture of the original 4 nodes of the ARPANET. So I grew up in Santa Barbara. Why was Santa Barbara one of those? That was my father's lab. Well, this year we passed more than half of the planet is connected. The whole nature of us as a as a human entity and a civilization are being transformed, and all of this began with federal research of a form that really who would know where it would end up. And we understood you could reach the moon, but we never understood the power of the collective intelligence of the entire planet. Here we are.
This is how we dream, and this is how we discover. And I think that to have this conversation and to hear your stories and to hear all of this in the environment that we're in now is so important, an environment where science and evidence-based thinking and research is frankly under siege. And doing more of it and funding it and supporting it and gathering like this to celebrate it is something that we need to do well and loudly. So join me, please, in thanking our amazing panelists, and thanks to all of you.